Good morning. In last video, we were discussed about numericals on block diagram reduction. I hope you gone through with that video. So in this video, we discuss uh, the one more type of numericals on block diagram reduction. So that is superposition of multiple inputs. That means if one or more inputs are given to the block diagram, how that particular block diagram is reduced into canonical form, and how to calculate the transfer function of that particular block diagram, so that we are going to discuss now. So here some several steps are followed. So that is step number 1, set all inputs except 1 equal to 0. So that means if number of inputs are given, here we need to calculate a single input response alone, and remaining inputs are set to be 0. So this is a step number 1 is to be followed. Then step number 2 is transform the block diagram to canonical form using the transformations. You all familiar with the transformation? That is block diagram reduction techniques. By using those block diagram reduction techniques, bring the block diagram into canonical form. Now step number 3, calculate the response due to chosen input acting alone. So whatever the input response we consider, by setting the remaining input response is equals to 0, then for that particular input response, so we need to calculate the output response. So this is the step number 3 is to be followed. And step number 4 is repeat steps 1 to 3 for each of the remaining steps. So we need to repeat the same steps, that is 1 to 3 for each remaining input response. Then finally step number 5 is algebraically we add all the responses. So finally we need to add all the output responses what we obtained by considering the single input acting alone. So this is the step number 5, that will get the total output of the system with all inputs are acting simultaneously. So these steps we need to follow for each and every example. Now let us consider the one example. So that is determine the output C due to inputs R and U using the superposition method. So here the given block diagram, it consists of two input response, that is U and R. So here we need to consider a single input response at a time by setting another input response is equals to 0. For that case we need to calculate the output response. Then finally the net output response is the algebraic sum of the all the output response. So this is the method is to be followed for solving the such type of numericals. Now step number 1 is followed, that so put u is equals to 0. So here u is set to 0, that means the output input response are as considered alone. Now the system which reduced to, if considering u is equals to 0, then system reduced to in this way. So that is drawn here. Now next step, so we need to write the output response for this particular block diagram. So that is the output C suffix R due to input R is CR is equals to Z1 Z2 divided by 1 plus Z1 Z2 into R. Now next step, put R is equals to 0. This is step number 4A. So we need to put R is equals to 0. Here we considered the input response U as a alone. So in this case the block diagram, that is equivalent block diagram, is represented like this. Now here we considered the summing point at the feedback, that is considered in a single block, that is -1. Then rearrange the block diagram. If we rearrange the block diagram, so equivalent block diagram can be represented like this. Now again this -1, it moved to the summing point. Now write the equivalent output response of that particular block diagram. So that is represented here. So the equivalent output response for the block diagram, so that is C suffix u, the output C suffix u due to input u alone, so that is equals to z2 divided by 1 plus z1 z2 into u. Now step number 5 is the total output is the sum of these two outputs response, that is C is equals to C suffix r plus C suffix u. Then finally we'll get the output response of the given block diagram, that is g1 divided by 1 plus z1 z2 under bracket g1 r plus u. So this is one example, and let me consider one more example, that is determine the output C due to inputs R, U1 and U2 using the superposition method. Now here three inputs are given, so that is R, U1 and U2. For these all the three inputs we need to calculate the output response. Then finally the net output response is what? The algebraic sum of these all output response in which a single input is to be considered alone. Now here step number 1 is followed, that is let u1 is equals to u2 is equals to 0. So here, so we'll set the two input responses 0, that is u1 and u2 is to be set 0. Then considering the r as a alone, then the system which reduced to in this form, that is, so if we consider u1 is 0 and u2 is 0, and these two blocks are in cascade form and these two blocks are in cascade form, then eliminate the cascade blocks, then the equivalent block diagram will get like this. Now next step is that for this particular case we need to write the output response, so which is given as C suffix r is equals to z1 z2 divided by 1 minus z1 z2 h1 h2 into r. Now step 2, so here now let the two input response is to be set 0, that is r and u2 are set to be 0 considering the u1 input response alone. So then the block diagram will be reduced in this form. So then again rearranging the blocks, so here z1 h1 h2 are in cascade form, so eliminate this cascade block, so this will become z1 h2 and h2 that can be represented in a single block, and this is the equivalent block diagram. So for this block diagram, so we need to write the output response. So this output response can be represented like this, that is C1 is equals to G2 divided by 1 minus G1 G2 H1 H2 into E1. Now next step, so here we set the two input response is equals to 0, that is R and U1 is set to be 0. Here we considered U2 input response alone, then rearranging the block, then we'll get like this, that means these two are in cascade form, that is h1 g1 g2 are in cascade form, eliminate these two cascade blocks, then we'll get that is g1 z2 and h1 that can be represented in a single block, then the equivalent block diagram can be represented like this. Now for this particular case, so we need to write the output response, that is C2 is equals to Z1 Z2 H1 divided by 1 minus Z1 Z2 H1 H2 into U2. By superposition, the total output response is the sum of these all input responses, output responses, that is C is equals to C1 plus C2 plus C suffix R. Then finally we'll get the output response of the given block diagram, that is equals to Z1 Z2 R plus Z2 U1 plus Z1 Z2 H1 U2 divided by 1 minus G1 G2 H1 H2. You just solve for this. consider the output response, that is C suffix R, that we calculate earlier, and even by considering the R input as an alone. Now C1 be the output response by considering the U1 input response alone, C2 be the output response by considering the U2 input response alone. So for all these output responses are added together, then finally we'll get the total output response of the system. Now this is one more example. Now let me consider the one more example, that is determine C1 and C2 due to R1 and R2. Now here you just observe, so two input responses are given, that is R1 and R2, and similarly the two output responses are given, that is C1 and C2. For this case we need to calculate the equivalent output response. Now how to calculate the equivalent output response, that we'll discuss now. Now solution, first ignoring the output C2. So C2 output response can be ignored here. First rearranging the blocks, we get if C2 output response is ignored, now only C1 output response is considered here. Now the equivalent block diagram can be represented like this. So in this case what happens, so G3 and G4 blocks are in cascade form, so that can be represented in a single block. That product is to be taken, that is G3 into G4, and G4 can be represented in a single block. So then here again two input responses are there, that is R2 and R1, two input responses, and here then C1 is the single output response. For this particular case we need to calculate the output response. Then how to calculate, again here the steps are followed. First step, you just set one input response as a 0, here set R2 as a 0. So if we set R2 as a 0, so then equivalent block diagram for that case can be represented like this. So this is the equivalent block diagram. So in this case, so here if R2 is considered 0, so these two blocks are in cascade form, then eliminate these two cascade block, then we'll write the product of these two, that is G2, G3 and G4 can be represented in a single block, so that is represented here. So this is, so then for this particular case we need to write the output response. So this output response can be represented as C suffix 1 1. So the output at C1 due to R1, that means output at C1 due to R1, so alone, so that can be represented as C11 is equals to G1 R1 divided by 1 minus G1 G2 G3 G4. Now for R1 is equals to 0, now this response can be obtained by considered R1 alone, that is R2, setting R2 is equals to 0. Now set R1 is equals to 0, R2 is considered input response alone. Now the equivalent block diagram can be represented like this. Now for this particular case we need to calculate the output response, that is C suffix 1 2, that can be calculated as, so that is equals to minus G1 G3 G4 R2 divided by 1 minus G1 G2 G3 G4. You just gone through with this, just to solve this. So don't listen the video blankly, you just go on solving the numerical, then we'll get the things clearly. Now so we got two output response here. So one is the output response, R1 input response as considered alone, and one more is the output response and the R2 input response acting alone. So now finally, so we need to calculate the so here finally we need to calculate the output response for this particular case. So that is C1 is equals to C11 plus C12, that is we can obtain that G1 R1 minus Z1 Z3 Z4 R2 divided by 1 minus Z1 Z2 Z3 Z4. Now we reduce the original block diagram ignoring the output C1. Next step is what? Here the output C1 is ignoring. We only consider the output response of C2. So here we just ignore the C2, consider the C1 output response. Now next case we'll consider the C2 output response ignoring the C1 output response. Then let me draw the equivalent block diagram. Then this will get the equivalent block diagram. Now for this case we need to calculate the output response. Here so we need to set the first R1 is equals to 0. It means considering the R2 input response alone. Then rearrange the block diagram. Then we'll get the block diagram which is reduced to in this form. That means these two are in cascade form. Eliminate these two cascade block. Then we'll get that equivalent block. That block is G1, G2, G3. Product of these two. Now finally the block diagram is reduced in this form by considering the input response R2 as alone. Then for this particular block so we need to calculate the output response. Now here the output response is considered as a C22. So the C22 is equals to Z4 R2 divided by 1 minus Z1 Z2 Z3 Z4 we can obtain. Now next case we considered that R1 input response acting alone, then R2 response is considered as 0. So the block diagram, the equivalent block diagram can be drawn like this. Now for this block diagram, so we need to calculate the output response that can be represented as C21, that is equals to minus Z1 Z2 Z4 R1 divided by 1 minus Z1 Z2 Z3 Z4. Then finally so we need to calculate the equivalent output response for C2, that is equals to the sum of these two output response, that is C22 plus C21. Then finally we'll get the equivalent output response of C2, that is Z4 R2 minus Z1 Z2 Z4 R1 divided by 1 minus Z1 Z2 Z3 Z4. Now this is about the output response, that is C2 is to be considered alone. So this ends the today's discussion. So that is superposition of the multiple inputs. So we'll meet in next video with some other points. So till then, be safe, stay at home. Thank you.